In this video we're going to look at traversability. Traversability is like those pictures we did when we were younger, where we try and draw them without going over the line twice and without taking our pencil off the paper. So when we're talking about networks, we're talking about graphs, and a graph is traversable if you can travel to every node, that's every point, on the graph going along every path, and this is the important bit, exactly once. Now there's two different things we're going to look at, and one of them is the Euler circuit. If you can do this, that you can draw it and you start at one node and you end up back at the same node, it doesn't matter where you start, but as long as you end up back at the same place, that's an Euler circuit. If you can do it by starting at one node and ending at a different node, then that's called an Euler path instead. Okay, so to work out whether a path is traversable or not, we need to know about the order of the node. And the order of the node, of a node, is equal to the number of paths going into and out of it. So let's look at this example. So here's our node, and it's got 1, 2, 3, 4 paths going into it. So that node has order 4, and we would call that an even node. And then if we look at this example here, we've got 1, 2, 3 paths going into it. So that node had order 3, and we would call that an odd node. Okay, so let's look at an Euler circuit. If the order of every node in the graph is even, then we have an Euler circuit. So here's a graph. This point has order 2, as will this one, because of course they're symmetrical. This one has order 1, 2, 3, 4, and all of these will be 4. So every node is even, so this is an Euler circuit, and that means that if I start drawing this with my pen here, then I can draw this circuit. I'll just end up at this point. If I start here, I can draw this circuit. I would just end up at this point. Okay, so now let's look at an Euler path. And it's an Euler path if there are exactly 2 nodes in the graph which are odd. So here we've got order 4, 4 and 2 again, but these ones have changed to be order 3. So we've got exactly 2 nodes that are odd, and that means that this graph now is going to be able to be drawn providing I start here and end here, or start here and end here. You cannot do it starting here, here or here. You know, I challenge you to really go and give that a try. Okay, how do we make an Euler path into an Euler circuit? So let's just have a look at this here. This has got order 2, this has got order 1, 2, 3, this has got order 3, and this has got order 2. So it's an Euler path because there are exactly 2 odd nodes. However, it says here, if we join 2 odd nodes with a common path, then we make them even, and thus we have an Euler circuit instead. Now it might be clear to you that if we actually had more than 2 pairs of odd nodes, let's say we had 2 pairs of odd nodes, then if we join one lot together with a path, we end up with an Euler path, and then we join the next pair together with a path, we end up with an Euler circuit. I hope you found the video helpful. Stay in field with Winfield.